Well, hi, everybody. I'm really happy to be part of this conversation. Thank you, Kamiko, for inviting me. It is very gratifying to see repair included in the materials management world. And I am here, of course, because reuse and repair are at the top of the sustainable materials management hierarchy. And because the EPA wants to see, and I'm quoting here, a change in how our society thinks about the use of natural resources and environmental protection. So what I hope to show you today is that repair is a strategy for helping to make exactly that kind of change in thinking. Our goals are to restore repair as a basic social value, to give our citizens the option to reuse and repair instead of always buying new and cheap. It is to rebuild the repair economy and establish professional repair as an attractive and viable livelihood. It is to strengthen the skill set within communities so that when the next hurricane hits the islands, everyone can meet it with greater self-sufficiency. So now I'm going to give you a set of statements that are meant to be provocative. Here's the first one. This is the axiom coined by Twitter co-founder Evan Williams. The argument can't be made that this is sustainable. Nature's perfect packaging. Have you ever been asked this question in the grocery store checkout? Here's a reality we are all very familiar with in our global economy. I'm going to have to fix that slide. The things we made are not made to last. They are not made to be repaired, not anymore, and seemingly less so all the time. So everyone on this call is very familiar with the mountain of e-waste, and you're probably very familiar with the phenomenon of fast fashion. And all of these things have given rise to the right to repair movement. And next. Okay, how does this make you feel? Are you seduced by the selling point, maintenance free? Well, maintenance free is a fiction, of course. And the fact is that when something breaks, most of us don't know what to do about it. Most of us are helpless. And how does that make you feel? This statement is our core belief. In fact, something that is fixed is more beautiful than it was before it was broken. And now here's a question for you all to ask yourselves. What skills do you have that you can share with your neighbors and with your community? There is an insight that we can trace back to Aristotle, that one of the greatest sources of human enjoyment is to enact one's knowledge. And the act of repairing involves troubleshooting, which to many people is an irresistible proposition. Repair Cafe, what is it? Repair Cafe is a free community meeting place to bring a beloved but broken item to be repaired by an expert who is also your neighbor. And that is the core dynamic, that the people who bring their skills to the community are people that you will want to get to know. One catch, this is not a drop-off service. When you bring your item, you sit down with the person across the table and you tell the story of what you've brought. When did it stop doing what it's supposed to be doing? What kind of noise does it make? When did it get that rip? When did it get that tear? And then you begin that conversation. And that conversation is not beside the point. That transaction, that interpersonal transaction, in fact, is the point. So repair is about all of these things. It's about extending the useful life of things that you care about or rely on. It is about feeding your curiosity about the way things work. It's about using tools and using your hands. It's about honoring, preserving, and passing on repair know-how. It's about sitting elbow to elbow at a work table with your neighbor, sharing skills, reducing waste, making friends. Okay, this is one definition of resiliency I think you all will recognize. Repair cafes started in Amsterdam in 2009, and the Netherlands was the perfect place for this idea to take hold. The Netherlands is a small country, long focused on beating back the sea and reclaiming the land, and the deeply rooted historical mindset is very much about how to live within limits. And yet, make no mistake, prosperity has allowed for plenty of consumer buying by the broad middle class, and the Netherlands is no less a throwaway society than is the US. Repair saves people money. Now, it used to be, of course, that every town had its repair shops. Everyone knew where to go when they needed something fixed. That know-how was close at hand. Of course, we all recognize that that is no longer the case, or seldom the case. And so you have something you really would like to keep. You really don't want to throw it away, but where are you going to take it? Lord knows the consumer economy is powerful. And the growing repair culture is a countervailing force. These are community initiatives that are creative and socially vibrant places for building awareness about the challenges that, in this case, the islands face. Self-sufficiency is a self-evident community goal. This is more than just the opportunity to fix broken things. Repair Cafe is built around the ethos of skill sharing. That is a mutually beneficial and empowering thing. It nurtures neighborly networks. Repair Cafe asks the community to look within. When we say bring a beloved or broken item, or simply downright useful item to be repaired with an expert who is also your neighbor, you are calling on the invaluable wealth within your own community. Now, our repair cafes are all volunteers, but you might organize yours differently. In other words, there may be compensation built into it. But what we are really talking about is building social infrastructure. This is a book some of you may have heard of, and if you get nothing else from what I'm saying today, I urge you to find this book if you don't know it already. Eric Kleinenberg tells the story of the 1995 heat wave in Chicago. In 1 week, more than 700 people perished, but it wasn't the people you would expect. And he performs a social autopsy to uncover the reasons. And the antidote he argues for is to build strong social infrastructure. And to do that, you need vibrant shared spaces. And that is what community repair will give you. So the goal is to organize and incentivize community repair. The goal is to rebuild the repair economy. And here we have the materials. Here we have several things that I'm guessing you are familiar with. And so materials recovery facility, resource recovery parks, radical reuse center, and circular craft centers. The vision here is of a materials resource recovery park that is fairly radical, but it is a theme park. You know, you can liken it to a theme park. This is not waste that is out of sight, out of mind. This is the rather magical transformation of waste into something very valuable. In fact, you're taking what had been considered waste and you are making it a valuable source of local capital. You're providing quality goods and services to the community and making it a destination. You're providing jobs and job training, and you are able to fund other community programs. And there are other examples of this that I could point to, but I am being speeded up here. So I'm going to just end with this slide. Repair is essential now more than ever.
Kind of want to talk about a few things. The first thing is, and I think it's from my standpoint on both the solid waste side, solid waste management side, on the and on the environmental side, it's getting the organics out of the landfill. There's been a lot of discussion of other recycling options and other diversion options, but the benefits to island communities of composting are just, there's a multitude of benefits. From the fact that we're getting the organics out of the landfill, not generating methane anymore, improving landfill operations, to the benefits of getting good nutrients back into the soil, because many of our islands have pretty poor soils. They haven't had millennium or more of building soils like you've had on the mainland. And a lot of those soils have leached all the organics out because of the tropical nature. So getting the organics back into the soil is another big benefit. So my thing is, it's probably the simplest and most beneficial thing you can do. It's also something here on Kauai, where I'm from, where I was working. One of our big success stories. We've, through a couple simple projects, and mainly just through mass public participation, have achieved about a 75% diversion of our green waste and other landscape waste from the landfill. We've got 3 regional composters that take the material from our transfer stations, where it's dropped off separately by residents, or take it directly from commercial haulers that are bringing it in from resorts and hotels. And basically, it's very successful. Hasn't required much in the way of promotion or resource use on the part of the county. And like I said, it's a major reduction in what's going into the landfill, because here I'm sure on all tropical or semi-tropical islands, green waste is a major part of what's going into your landfill. Right now, we're in the process of expanding that to handle all organics. I'm working on food waste next. And so I think that getting the organics out, getting them into your soils, getting them used by farmers and agriculture is probably the best thing you can do. One of the things we did in Saipan was dealing with tires, and I'm sure a lot of the islands have problems with tires. First thing is, tires are really something you don't want in your landfills. In many cases, they're not allowed in landfills, and they're a problem to handle almost any way you handle them. So the fact that it takes a little bit of extra effort, an extra cost, is well worth it, because there's really no other solution for tires in island communities other than shipping them back to where they came from. We used a baler, a downstroke, double downstroke baler, fairly similar to the kind of balers that shopping centers and markets use to bale cardboard, but more heavy duty baler. They created bales of about 100 tires. They weigh about a ton. We use them as retaining walls around. We initially used them as retaining walls around our landfill, and then started using them as just low little barrier walls. There's some tire bales.
Yeah, these are, I just quickly, while you were speaking, I just tried to pull up some images, just doing an internet search. But these are what the bales were like. And then John coated them with gunite. So they had like a,
yeah, you basically take chicken wire, wrap the bales are already wrapped in heavy duty wire when they're baled from the machine. So these are all stable bales. You're cover them with chicken wire and spray them with gunite, and you get a nice little barrier wall. This was a little bit extra thick because we had lots of tire walls, tire bales. But one thing you need that we had in Saipan was a commitment by the local public works people or other people to use these bales. But they make excellent retaining walls. They make excellent low barrier walls around a refuge transfer station or around some of the facilities where you want to put a fence or a other barrier, and they're easy to stack. So.
Yeah, and if I might chime in, I was on the Zika task force a few years ago, and tires were definitely a cause of concern because the transmission opportunities from the various vectors, the mosquitoes for mosquito-borne illnesses like Zika and dengue and chikungunya. So so this obviously reduces the amount of water that can seep into the bale. It also reduces the spontaneous combustion potential because it reduces the amount of airspace between the in the surface area of the bale. So, John, there was another question about at one point about the straps rusting and the whole thing exploding. Could you speak to that, please?
Yeah, the straps that the bales are wrapped in when they're baled are stainless steel. They have they're very durable and have a good lifetime. But yeah, there's always the potential of them rusting. The issue is twofold. First is that if you contain and coat the bales with gunite or some other material, it reduces that potential. Secondly, and we've seen this happen, is that the tires, once they are crushed and baled into it and compressed and stay in that state for a few weeks or months, even if the tire bales, the tire wires rust, bales won't explode. They will crumble if they're not contained. But again, that's something you can do by, we got some pictures there.
Yeah,
Anyway.
I was able to pull this up too.
Anyway, yeah, so the tires, they've been used in other places. And again, the bale that we got was a company called Encore, ENCORE. You can find that on the website. They've used these bales for civil projects across the country to contain streams, to contain walls, and you can go to the extra extent of using concrete even more than just chicken wire and gunite. So it's a good thing. The issue is that tire bales are, tires, like Kamiko said, are a problem that we have to deal with because we can't put them in the landfill. And if there's no other solutions, taking this extra effort can be worth it. And it's one of the things that I find in a lot of the solid waste options or solutions is that getting people to do things can be difficult when it takes an extra effort, and just throwing it in the landfill is a simple solution. The things with tires is that's not a solution, so you really have to take that extra effort. The final thing I wanted to talk about was glass, because Kamiko mentioned that. We're currently working with an operator who takes our glass containers down to 3/8 inch minus aggregate. It's similar to the Andela process. basically they took an old hammer mill and modified it to turn out an aggregate substitute, and we're using it for a number of low-value fill operations. The problem is that glass doesn't cause any problems in landfills, so there is a cost to process the glass versus just throwing it away. And the product that we're turning out has little or no market value. We've gotten people to use it for a lot of non-structural projects, but our operator is having problems getting rid of all the glass, all the ground up glass.
And Cynthia Andela will be is up next and will be speaking
Yeah,
about
and
the
maybe
glass
maybe she can talk a little bit about that. What my thing is that once the glass is produced, the county or the community, the government agency that's in charge needs to set up programs or projects where it's required to be used. I've been, like when I was on Maui, the county would specify the use of glass in asphalt for some specific projects that they were contracting for. And that creates a market and creates a use for it. So unless the public entity gets behind it, oftentimes you have a problem using that material. But I've seen it used in glass fault. I've seen it used really effectively as backfill behind retaining walls where you need the drainage fill. The other thing that we did look at, and it's kind of in limbo right now, is looked at the possibility of producing a silica sand substitute. That is taking the material down to about 1/8 inch minus or smaller. We found a contractor that could produce a silica sand substitute that met PGA specs. And on our island, and I'm sure on most islands, there's a high demand for golf course construction and maintenance for silica sand. You can't use coral sand for those kinds of operations. And right now in Hawaii, on Kauai, we're importing silica sand from the mainland West Coast or from Australia at a high cost. So you're producing a high value material that has a high demand, and we found a lot of golf courses that were really interested in the product, but because of, I guess we'd call it lack of county support, the project's kind of gone off into limbo right now, and this is mainly due to, and I'm sure all of you are facing it over the last couple years, the reduction in our staff and our resources. Our county solid waste people are operating with about half or a third of the staff that they had 4 or 5 years ago, trying to do the same jobs. So just running our traditional drop-off recycling and our composting and our landfills it has overwhelmed them, and so some of these new projects have been put on the back burner. But I don't know if Andela can produce this material with their machine, but if it's possible, or if you can find an operator that can produce a PGA spec sand, your golf courses will love it, and they'll pay $100 a ton or more for it.
I've been doing the glass recycling equipment and systems for over 25 years, and Andela Products has been making a glass pulverizer with the idea of taking a local waste, turning it into a local resource. So the idea of turning glass into sand is what we started with and what we're very much doing every day. with our equipment in many places, a lot of islands. So like John was saying, what the real issue is on the islands now is sand. And yes, that's what we are doing. As we go through the Andela pulverizer, probably about 70% of the product on the first run through the pulverizer meets the specification for a like a C33 concrete sand or a number 4 minus sand. If the customers want to have only a sand product, we simply add one more conveyor to the system. So I'll cover that in my presentation. But from a bio point of view, that's what my company's been doing as far as building recycling equipment. I've also been involved in starting a couple of companies that are involved in the glass recycling itself. The one that you'll find online that's most active right now is Ruby Lake Glass, and we recycle glass into a color-coded glass product. So I've kind of got two hats going on. One is making the equipment, and then the other one is a recycling company that's making a value-added product. My background, I'm an engineer by degree, but have been running my own business-wise for many years. The local collection, processing, alternative markets, and especially relevant on islands because it doesn't make sense to export something like glass that's heavy, and there's a lot of energy used to export it distances. So the island makes a lot of sense. But you got to make a product that's safe handling, fine granular, no sharp edges. And so you can tell from the pictures here that you got a sand product, which is the hand is holding, and you can also make a aggregate, a bigger, stone, pea stone type product. But if you don't want to have the larger product, you can just make all sand if you'd like. What kind of material? The nice thing about making a sand is you can take anything. So if the island's got just bottles, that's fine. But if there's plate glass, that's fine too. If there's some ceramics, all of those things can go together because they're all amorphous silica. So what does the system actually do? The glass cleanup system is one item we have, which is more applied if you have a material recovery facility with a lot of shredded paper. So that's used at the material recovery facility to blow out and separate some shredded paper. But then you go into the Andela system where you get these products, and there's like I'm listing two products. You can do a 3/8 inch minus, which is about 10 millimeters minus, or you can make a just 4 mesh minus 3 to 5 millimeter minus glass sand. And I call it 4 mesh or 3 millimeter minus. That's a sand size, and if you have materials that's wet, they don't screen to much smaller than a 3 millimeter minus unless you dry it. But there's a lot of material in that size from 3 millimeter all the way down to 0.1 millimeter. Because of our design, we have flexible impactors. So the glass is separated from the other materials because the impactors only break the glass down into the sand, but leave the plastic, the papers in a larger form. So we can just screen them out with a little trommel screens or big trommel screens. They're part of our system. So the system is a very simple pulverizer or crusher combined with a trommel screen, but because of the way it crushes it, it doesn't grind the non-glass down. There's no internal screens or items that would make it too small. So I'm going to show you a bunch of pictures, and I'll tell you where they're also located on different islands. A system is made up of our pulverizer or breaker, and that's a round chambered type item. You can see it on the corner of the little GP Mini here. Hoppers and conveyors and are provided as needed. And again, selective reduction means you only break down the glass, not the rest of it. All made in the United States. So our little one, the GP Mini, is the smallest one we make, but it is just as robust as our larger trommels. It's just that it has a very small screen and it's very compact. There's a lot of these out in all around, but I think we've shipped a number of them to Australia, which have then ended up in the South Pacific Islands. We're making one right now that's going to end up in actually Guantanamo Bay. That's an island, and a few other places. We have the GP Mega Mini, which is a little bit bigger because the screen's a little bigger and you got an in-feed conveyor so you can dump more material in versus just a small hand feed. And again, that's quite popular. I'm trying to think what islands those are on, but I'll have to get back on that one. So
Cynthia, we had there was one that EPA helped purchase for the VI, right? Was that one of yours?
Virgin Islands, yes, probably, but I'm trying to think. I think that was probably the GP Mini or the Mega Mini. I can't remember which one.
Okay, I think there was an issue with the bottle bill and so on and so forth, and this, that, and the other thing happened, and it ended up sitting unused.
Yeah.
So I don't know if it
that was
can.
unfortunate because that was a crusher and a little pulverizer. You're right, but because of the plan they had for recycling, it didn't get funded, and they just kind of the whole project died. Shame, isn't it?
Yeah, I mean,
would
if it
hope
can be
it
found and
started-
resuscitated, that would be great, but I don't even know if people know where it's located.
No, I know. I know. I've tracked it for quite a long time. I don't know for sure where it is anymore. Yeah, it was by a nonprofit there, and yes, it absolutely can be put into service because it's the same size as the GP Mini and Mega Mini, or even the size of the GP05L here. I believe it might have been that size. And this GP05L, the 1 to 2 tons an hour, that's on a lot of small communities, including St. Martin. The GPT-1 here, 3 to 5 tons an hour, that's on Martinique, Art, Guadeloupe. So what you're seeing here are just real typical systems for islands and small communities. This system here, 20 ton per hour, that's actually a large system, but I wanted to show this because you can see how this yellow conveyor here that comes out with this, it's called the stacking conveyor. That's all sand sized materials. This system is set up to just produce sand. And when they're producing the sand, there's a truck that just comes up here and this tube goes right into the truck and they fill up 20-ton loads at a time, making sand and ship it to, in this case, this one's in the United States, but they're shipping it to somebody who's making insulation, I think, and they needed a sand size. So we can configure the systems, whatever the need is. A couple more pictures of the individual pieces of equipment. We make a surge hopper so that you can load it with a loader. If the material's coming in, it's put in a bunker. And then there's a reciprocating plate feeder on the bottom that just shovels it out and makes it automatic as far as loading goes. The pulverizers or crushers are the workhorse in the middle that does all the work and turns it into the glass into sand, leaves the other materials large so that when you hit the trommel screen here, this is a rotating screen and the fine material falls out the bottom here. And you can have some sand size fall out, some aggregate size, and then the trash comes out the end. I've actually seen like Walmart receipts go all the way through here and come out completely whole at the end, or corks come out completely whole. Even if plastic bottles, they'll go through, they'll get beat up, but they won't get shredded. So they just come out the end. So it's a very forgiving system.
Thank you.
Yeah, this is some of your numbers here on, if people want to know, I just lay it all out here. If people want to know kind of what the range of pricing, your operating costs, depending on what you need, inside, outside, and so on, because people say, well, what, these are typical questions I'm answering all the time. Of course, you got your economic development, your reduced carbon footprint. Health is a big thing because it's not crystalline silica, so you don't have to worry about the dust. It's not considered dangerous. It doesn't give you scar tissue in your lungs or any health detriments. And if you use it in designs, it's a benefit. Amorphous silicate, just again, non-crystalline, but why is it good as a sand on the islands? You know, it's inert, it's hard, it's stable, it doesn't leach away and break down. So like you say, whether it's golf courses or sandblasting, abrasives, or just a replacement, even on the beaches, you won't end up having it deteriorate. It's great for filtration because of the fact that it attracts water to the surfaces of particles. It's got a negative charge, so there's less surface tension, and it works really good for filtration. So I won't get into the details here, but if you want to know more, you can always ask me those questions. So expanding the options for glass. You know, the container manufacturer and insulation manufacturer has always been the core and still makes sense if you're near a container or insulation manufacturing company. But if you're not, like most islands, you got to think of, you know, one of these other and many other type of uses. But you have to have a quality material. So then I said, okay, let's show you some island installations. So that's what I was pulling out some pictures here for Kamiko and putting them out there. So like this is, I believe this is St. Bart. This is Bora Bora. This is Guadalupe. So we got, you know, South Pacific, the Caribbean. But you can see here, you know, kind of the different two sizes, like a sand size and aggregate size. This one in Bora Bora has got the recirculation conveyor in, so they're just making sand. And that's what you see here. It's a small GPO5 system, but it goes up here. The sand is dropping into this container. The trash comes out the end, and this conveyor takes the gravel size material, puts it right back in. And so they're making sand, all sand. This is a picture of a system that's been out on the island of St. Martin in the Caribbean, the French Antilles. And it's been a workhorse there for years. I forgot how old this machine actually is. But it's over here making sand, making gravel, and I show some pictures of those two things. And they've used it in concrete products, so these bunker walls in the back. I show some pictures of the glass embedded in the concrete bunker walls. So they've taken it, made concrete products that have made, he said, these bunker walls are great. They are really strong concrete, and it is something they can use locally. But I took a picture from the top of the recycling. The glass is way up on kind of on top of a hill, and I took a picture downward. I thought it might be interesting to see how, in the Caribbean, these landfills and recycling centers and so on are right. You know, everything's running off into the ocean. We've got a beautiful Caribbean ocean. You really have to have a good plan so that you do take care of things. And on St. Martin, they've been working on doing that. They're actually renovating an old landfill, making a properly lined landfill, digging up the old one, recycling anything out of the old landfill they can, including mulch. This is a white goods here. That's a maintenance building. They have separate areas for steel, glass, compost. So they're just doing a really good job of taking an old landfill, digging it up, recycling everything they can, and putting it, what's left over, in a new line landfill and recycling a number of products. And this is a bunker with glass in it, as well as bunker walls made with glass. You need to have an engineered construction aggregate. So if you're going to use it in glassfault, you really should use a number 4 minus sand, because if you use anything bigger than number 4, like you're using more of a 3/8 gravel, then you start getting stripping, and people have said, oh, glass fault's no good because the glass falls out of it. It's size matters. Got to be smaller. Got to have something that looks like sand for the construction industry to like it. If it looks like broken glass with garbage in it, they don't want it. So if you got a nice sand, you can build a beach. This is a filtration at a landfill. They were building a leachate collection field, but you can use it just as a trenching. But you can definitely use it as landscaping. It will retain the water. It'll keep the bugs from going up through. And you say, well, how does it retain water? Because the water is attracted to the surface of the glass. It holds it on the surface. So if you have like a glass sand, you have a lot of surface area, and you have a lot of moisture attracted to the surface. So the very top of the glass will dry out, but if you dig in a little bit, you'll find moisture just below the surface that will be held there and available for your plants. And of course, it's got to be safe to walk on and play in food stand. And that's my presentation.
Good afternoon, everyone, wherever you are. I'd first like to start off to say that we're in a hat trick situation where we've had 3 hurricanes in 3 weeks. So can any of you guys match that? So right now, we are having a hurricane just passed to us, actually, as we're speaking, and later on tonight. If this continues, we will need a waste management system because it'll be all blown off island. So I'll get started. Okay, so I'm Clarkston, Trott, solid waste manager. My predecessor, Mr. Hunt, had this position and happily passed it over to me. So I've been working in government about 30 years and waste management about 25 years. So I started off and worked my way up. over the past years. Cynthia, I believe, if you remember me from about 20 years ago when we first met. So anyway, the comprehensive waste management system, I'll try to not get into too much detail because it's so much that we can talk about in each of these areas. But if you go to the next slide. Okay. So back in the early 90s, we only had one landfill which captured everything. And because of the size of our island, we couldn't continue to do that anymore. So we developed a comprehensive waste management plan. So what we've done is we've split all of our waste management systems up into 5 interdependent facilities. Next slide, please. Okay, so here we are. Bermuda is 20 square miles, 65,000 residents at the moment, probably somewhere around 650,000 visitors a year. So if you just take a plan view of our 5 waste management facilities, there you will see where they are as in proximity to the rest of, to each other and also the island. So there we are, 20 square miles. And if you are able to see, most of it is developed. And that in itself has made us unique in what we had to do versus areas where there was plenty of land available for landfills and so on. So we were pretty much forced to act because of our size and our population. Next slide, please. So there are the facilities. And I'll talk quickly about each of the facilities. Our main facility for capturing Bermuda's burnable waste and municipal waste is the Tynes Bay Waste to Energy facility. And as the name states, obviously, it's an energy facility derived through our waste. Now, we capture currently about 60,000 tons of burnable waste that's sent through the Tynes Bay Waste to Energy facility. Its output is about, in total, at this time, about 7 kilowatts. I'm sorry, megawatts. And we have plans to add a third stream on that as well. Now, the plan itself, I think, was what, about $200 million initially? Or somewhere in that?
The initial 79 million.
79 million.
Yeah.
Anyway, so to put that third stream on, we're looking at adding probably or needing about another $150 million for the future. So that is the main disposal of our waste. It reduced the waste to about by 80%?
90%.
About 80% right now. 90 when Mr. Hunt started. So so what happens? What is the byproduct of that? Obviously, we have ash. So from the 80 tons or so, or the ash that comes from that plant is then taken to the airport waste facility, and then I'll talk a little bit more about that once we get down to the facility. Our next facility is the compost facility. So that's where we take all of our organic and horticultural waste. Right now, if you go down to the next slide. Okay, so we've got a plan of each of the facilities. So if you can all see the facility to the top right, that's our compost facility. That was previously our early waste disposal area. So what we've decided to do is to turn that as into our compost facility, and it does the dual purpose of making compost and also covering the previous landfill. If you see that the same slide, you see that little black area to its left, that is actually marsh. So now the term marsh folly, the folly of it was that when we started, it was all marsh, and over the past 60, 70 years, we have filled it in and gone probably 70 feet above that marsh water level. Now, the compost itself, we haven't really started a program in disseminating that. So we do have a lot of compost we can, in fact, utilize. Now, hold on a second. Okay. Okay, so we have about, that's about 30 acres of land right there. And we intend to actually try to use some of that compost to cover some of the other areas, and I'll move on from there as well. The next one would be our materials recovery facility, and that is, let me see where that is. Okay, so if you come to the left and then go down right there, that's our materials recovery facility. Now that plant in itself is oversized for our needs. Right now we are capturing about 50 tons a month of recyclable materials. We only recycle TAG, it's tin, aluminum, and glass. Plastics, obviously, we can use for fuel at Tynes Bay. We've also started to branch out and also recycle electronic waste, to a small extent, some white goods. So we're looking at dealing with air conditioners, refrigerators, and so on. And so it's the operations there is coupled with somewhat of a demanufacturing plant as well. So what we're trying to do is to get the metals which have high recycling value, tin, aluminum, copper, and the sorts out through demanufacturing. And then the rest, the tin and aluminum, we bale and send to the United States. We were talking about glass, so let's quickly get back to that. So we're talking about 600 tons, not much, 600 tons a year of recyclables that comes through that plant. That's collected from households. The plant is designed to do probably 10 tons an hour. So you can see that the plant in itself doesn't get much use. Of the recyclables that we do receive, I would guess that at least 70% of it in weight is actually glass. And so it is screened and broken down, and we store the glass on the left side of that building. If you can just, Kamika, move your pointer to the bottom left, right there, right? Go a little, right there. Yes, all that is glass. Now, what we intend to do with it, because we don't have a lot of it, as far as the size of the island is concerned, is we use it as sub-base drainage medium. Now we're about to embark on one of those plans for one of our soccer fields, and so that's going to take a big chunk out of it. We've also used it on golf courses, and we've already some of the tests that Mr. Hunt was talking about, so we've grown stuff out of it as well. But what we're moving on to now is actually creating slate, so glass slate. Now, if any of you are familiar with our roofs are built out of slate, and we have a shortage of that. So what we're going to do is start to combine that with concrete and see if we can build that to be a usable commodity on island. We haven't ventured into using it for roadworks. It's also available to us, but at this time we haven't ventured to do so. If you move down, just down, where are we? Hold on a second. Okay, across, right? Go down one, right there. That is our special waste facility. So anything that's hazardous or in fact cannot be taken or disposed of at any of the other facility pretty much goes there. Now, we import everything, so there's no real manufacturing here. Anything that we send off island basically is waste. So, and also hazardous, and also the hazardous materials. We, in fact, is there someone here from waste management? No?
Yeah,
In
I
fact,
believe there's a number of people from Waste Management Authority, including the executive director and his staff.
okay, wonderful. So they may know that we are moving our asbestos to the Taliton facility, and that was a major problem for us to address the asbestos. So if you were to take your pointer over to the left, right on the MRF screen, over a little bit more, over to your left. Left. And you see all the sea containers on the next slide? Go over
over
some
here?
more.
You mean here?
Yes.
Okay.
Yeah, that is all of our asbestos that we've abated throughout the island. So we started out with 800 containers. Right there now, there's about 600 containers left, of which most of it will be sent abroad if we can continue to do so. And some of that we will have to use locally as well.
Wait, where is all the asbestos from?
This is all from the buildings in Bermuda over time. Some of that stuff was there probably 40 years ago. So what we're trying to do is to get asbestos out of buildings.
Is
So
some
the
of this
government,
asbestos from asbestos in the concrete?
yeah, what we call transite embedded in concrete for roofing and sheeting. Is that what you're asking?
Yes.
Yes. A lot of that is what we call transite sheeting that was on the roofs. It could be encapsulated and so on, but then again, I can go into that for an hour or so. But a lot of that, it has been brought to us, the government, to dispose of, and so that's what we're trying to do is get that off the island. Okay, the last facility would be our inert materials waste, the airport facility, which is right to the top left. Okay, so that there is where we take, our cars, our white goods, our metals, our rubble, and all that sort of thing. And it is somewhat of a landfill. It also reclaims land. So we're trying to keep it as clean as possible. And that in itself presents its own challenges, as some of your previous presenters had mentioned. Cars, tires, and the lot. So that there now has grown to, I guess, about 50 acres. And we're still grappling with how best to get rid of the materials there, because as an island that's 700 miles away from the United States, all the cost in that is in transportation. So any gains that you get. Pardon?
Oh, Mr. Tenz, I was wondering, I'm sorry, I didn't mean to interrupt. Are those materials separated such that they could be harvested later if you did find a market, or if you wanted to ship something off island? So essentially monofills.
Okay, they run adjacent to the airport, so we have to be mindful of what we have there as far as radar and so on, navigational, and also from the scenic part of it. So what happens is that we will store some of that above ground, but at a point then we would start to push it into the ocean and cover it and create cells.
Oh, what I meant was, are the materials separated? So the tires are separate from the metals are separate from the plastics, so on and so forth? Or I'm not sure if you have plastics, you probably burn them, but.
No, we don't require folk to take the tires off. In other words, we have to only ensure, because we're not, we haven't got a program in place yet. The only thing we really are concerned about is the fuels and so on. So the tires can stay in the glass, the fluff, but the liquids have got to come out, and we take care of that. And it's the same for refrigerants as well. So the refrigerants and so on, we try to capture them, and that would go back through the special waste facility.
Thank you. And then in terms of the shipping, so I imagine there's not maybe necessarily so much that is exported from Bermuda. So have you been able to work out something with the shippers such that the empty containers going back, you could potentially put some commodities in at a lower rate?
That's exactly what we have done. And in fact, when it comes to the recyclables, we normally have a unit that returns to us. So anyone who's familiar with the island knows that we have small streets, and normally the containers are 20-foot containers. But in our case, we're able to get 40, 45-foot flatbeds to make it a little bit cheaper for us. With the asbestos, though, because of what it's carrying, we try to send it up to Talitong, get it dumped, and then the containers will return to us. So, yes, we do have an agreement with the shippers for reduced costs.
Thank you.
Go ahead. Were you asking me something?
No, I just said thank you.
Yeah. Okay. I won't drag this on much more, but just the next slide. Okay. So that's the percentages of what we are capturing here. We do have a waste audit from households, so you can see 62% is burnable. What is the other one? 21% is recycling and composting, and then we would landfill using that term at the airport 17%. Okay.
Yeah, let me just also state that from the waste Times Square waste treatment facility, what they use in-house to power the plant is self-sufficient, but then they also export to the grid a fair amount of what is generated, and they also produce through saltwater RO about 1 million gallons of water a day, and that helps us definitely in Bermuda whenever there is a bit of a drought. But so that's one of the saltwater RO plants that works. It's right on site, so they're able to take the waste that is incinerated. We produce energy, and we also produce fresh water from saltwater RO. So that itself is a diversion method that we're using, and then it also helps the economy and helps overall what we.
Okay, yeah, we can yes, that's a diversion, and we can go into detail in any of these facilities. The next slide, please. Okay, and those are the numbers in tons, thousands of tons. Sorry. So you folks can see that there. You see how it's all broken down. And so in 2019, we captured around approximately 86,000 tons of combined waste. All right, next slide. Okay, and from the household audit, goes to show you what we've got as far as what people discarded and its makeup. Okay, next slide.
Are you doing any anaerobic digestion?
No, anything that we use would be in the compost, through the compost system. So if we're going to use food or sewage sludge or whatever, it'll be added to the composting system.
Okay, thank you.
Okay, next slide. Excuse me a minute. Okay, so because we need obviously participation from the public, we have given them a comprehensive list of what they can do with everything that they generate at home. And so this is mailed out and given out to the public to help assist in compliance. As you can imagine, it's a nightmare trying to get everyone to comply if they don't know what is required. And so we have broken down everything as best as we can and given it to the general public to let them know what goes where and what to do. So that's an overview of the waste management system as we have it now. So if there are any questions, then